Okay, well, we're talking about some other things that are proportional besides the triangle stuff. Although technically this is a triangle, but it turns out when you have a triangle with a parallel line in it, uh, well, you guys remember when lines are parallel, like these angles are the same, called corresponding angles. You guys remember this picture? Those are corresponding angles. Yeah. Anyway, and these two would be corresponding angles. So this little triangle is similar to the big triangle. So that means all these things are, like the angles are congruent, and it means the sides are in proportion. So like, we'll call it A on the little triangle matches what on the big triangle?
AB.
A plus B. And C on the little triangle would be like C plus D on the big triangle. So those are equal. But it actually, so that's true, but it actually turns out that you can also just do A over B equals C over D. Even though B is not a part of the, B is not a side of a triangle, it's just part of a side, so, but it still works. So that's the new thing. And you can do it a lot of different ways. You can say A over C equals B over D, or B over A equals D over C. As long as you follow the pattern, it works. It's with all ratios. And if that's true, that means if these lines are parallel, okay, these lines are not parallel, by the way. Draw a little bit more. I guess W, X, Y, Z. Okay, it turns out, because these are like the lines inside of a triangle kind of, but it turns out these are in proportion too. So like W over X. So all these pictures that they're showing us, they will be in proportion. Okay, they're not going to try to trick you with that. This over this equals this over this. Or you could say this over this equals this over this. Or this over that equals that over that. Works a lot of ways. And there's one more. This one is the most surprising to me. I don't know what the theorem is for this one. But if you draw an angle bisector, you guys know what an angle bisector is? Splits some angle in half like that. It turns out that it creates equal ratios. I'll just use just A over B equals C over D, basically. So it's what you might guess. A over B equals C over D with an angle. So these are kind of like all the non-triangular proportional stuff that we can use. This, even though these are triangles, this is really not a triangle. Anyways, so number one, we're just supposed to write a ratio for these pictures. So what would be equal ratios on number one? Not a trick question. You could probably just guess and get it right. There are ways to get it wrong. Okay, if I said C over D equals what? B over A. That would work. There's a bunch of different ways to write it, but that's one of them. Okay. Number two is just about that easy as well. Actually, but let's do it together. That way you don't have to worry about grading it, because there's like 6 different ways of writing it. So, what do you guys think for two? Somebody.
W over Y equals X over Z.
Okay, W over Y equals X over Z. That's fine. Number two. That's the way the book wrote it. How about number three?
B over Y equals A over X. Or
B over Y equals A over X. That's fine. A over X equals B over Y. X over A equals Y over B. All good. Okay, 4 is kind of like that. I'm not going to do 4 though. So number 5, T over U equals W over blank.
Yes.
T and U on the left equals W and blank on the right. X, right? U would go with the X. On B, V over T, so the bottom segment over the top segment equals what over W, right? V goes with the Y, so we're missing the Y. C says X over what equals U over V. So U and V are the bottom two on the left. So X and what are the bottom two on the right? Y. Y again, yeah. D, trying to trick us a little bit. W over X plus Y. So those are like the top segment and the bottom two segments on the right. Equals T over U plus V, bottom two segments on the left. How many things were there where it's maybe even 2 sets? Plates?
Like we will buy dishes there, maybe
Dishes?
Finest China.
Finest China?
And we'll dine well.
I figured out what your guys' Massachusetts reference was yesterday. Okay, number 7, state whether each proportion is correct. So these are yes, no. Does A over C, is that going to match B over D?
Yes.
Yep, it is. Those do match. Does B over A match D over C?
Yes.
Yep, that is following the pattern. Does C over D match B over A? No, they're going the wrong direction. And last but not least, does D over A match C over B?
Yes.
Well, actually, it doesn't work like that. No, it can't jump across like that. No. Can't go diagonal. Let's put it that way.
You pay with us.
Determine whether they're parallel. Okay. On number 1, remember how I said if the lines are parallel, those things are in proportion. So on this one, if they're in proportion, the lines are parallel on number 8. So does 2 over 4 equal 3 over 6?
Yeah.
Yes. So the explain why or why not, all they wrote is 2 over 4 equals 3 over 6, and yes, that's all they wrote.
Okay.
So for that trick to work, the lines have to be parallel. Anyway. And then if they're not equal, just put a no. Okay, number 9, write and solve a proportion to find the missing. So how do we set up a problem to solve for 9 for x? Just be x over 6 equals 2 over 3. That would work. And then guess what? 3 times x equals 6 times 2 is 12. 12 divided by 3 is easy peasy. Okay, for 11, 27 over 9 equals 36 over x. So 27x equals 9 times 36. That's kind of big. Okay, if we divide by 27, I think that's going to be 12. Yep. How are we gonna set up 13? Mystery of mysteries. 14 is slightly tricky there. I might have to help you guys set up 14. Any ideas for setting up 13? Did you say 20 over 15?
Yeah.
Okay, she said 20 over 15 equals 12 over 2x minus 4. Which is fine. But how did we cross multiply when we had one of these things?
You cross multiply both.
Yeah, 20 is going to be multiplied with this. So you could write with the parentheses. It looks like that. Kind of the decimal. What'd you get? 2.5. Wait,
That's not right.
That's not right.
it's 6.5, right?
Yeah. Yeah, cute.
Okay, 14's a little bit different than the rest of them, so maybe we should talk about that one. How could we set up 14? I'm not gonna solve it though, we'll set it up at least.
14.
Yeah,
Do, what is it? 8, 5 equals x, no, y over 10 maybe?
yeah, so the problem is we don't really know how long. Yeah. Okay, we could do 8 over 5, it would work with that. But, and we know what goes with the 5 would be the 10 on the other side, but what goes with the 8? Any ideas?
X minus 10?
Yeah, x minus 10. You guys see where I got that from? The top part of that triangle, since the whole thing is x, if we wanted to find just that top part, we'd have to do x minus the 10 on the bottom, and that would leave us with just the top part, right? So you can set it up like that. I think it would probably work if we did x over 10 equals 13 over 5 also. Let me see if that actually works. Yeah, it does work that way too. Okay, number 15. Just kidding. Just trying to freak you out.
Okay, well, you did work.
I heard you say no, 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 no. It's like you must be looking at that one. Okay, number 17. Standing on top of Pine Mountain. So, what's this picture look like? Does it look like number 1, 2, or 3? On number 17. Does the picture look more like 1, 2, or 3?
3. Wait, what are you talking about? Picture on 17?
Yeah.
Then what's 1, 2,
does 17, the picture look more like problem 1, problem 2, or problem 3?
One.
Problem 1. It's basically a triangle. Since these mountains are, you know, we're doing the altitude that's going straight up. Those lines are parallel, so we can just use ratios. Okay, anyway, standing on top of Pine Mountain at an elevation of 5871. I think Pine Mountain's the big one. So the tall mountain is 5,971 feet. Buck Ridge, the smaller mountain, is 1,957 feet. How far is Gilder Creek? Oh, I didn't read it enough. Okay, standing on top of Pine Mountain at an elevation of 5,871 feet, Dan sees Gilder Creek. You guys see in that picture they put a little blue wavy line out here?
Yeah.
So this is Gilder Creek. Let's put a G there. Just beyond the top of 1957 high Buck Ridge. So he's looking, here's Dan up here. Whoops. Whatever. He's up there, okay. He's looking down just over the ridge. How far is Gilder Creek from Buck Ridge? So that would be Gilder Creek, Buck Ridge. That's right there. If Buck Ridge is 6,500 feet from Pine Mountain. Buck Ridge, Pine Mountain, 6,500 feet.
So would you do 5871 over 6500 equals 1957?
No, that's not going to work on this one. 5871 is a side of the big triangle, right? So when we match it, we need to use a side. We either need to use the matching side on the little triangle or another side of the big triangle. So anyway, 5871 on the big triangle matches what on the little triangle? 1957. So we can do that. So we're going big triangle to little triangle, right? Okay, so then we need to go big triangle to little triangle. So what's another side of the big triangle?
6500.
No. 6,500 plus X. Yeah, we do need that plus X on this one. And what's the corresponding side on the little triangle? X. Got a couple X's on this one. Are you serious right now? Okay, 5871 equals 19, cross multiplying here. Them some big numbers.
That's a really big one.
Might need some calculator assistance. What's 1957 times 6,500?
1272050.
That?
Plus
12 million something?
so first,
Did I write the number right?
yeah.
Okay, what do we do when we have X's on both sides?
Get it on.
Subtract, we want to move them to one side. Ugh. I think that's right, maybe. But what would our last step be? Let's see if we get it right.
$2,250.
That is right. and draw it for the whole thing for us, I guess. Okay, let's go this way. A, B, C, D. Something like that. A, B is what we're looking for. So I'll put the X way up there. AB is what we're looking for. AD is 8, AC is 12. What else we got? DB is X. BC is X plus 2. Oh, well, I can't use an X, I guess, because we're using it right there. But, alright. Let's solve for X, but X is not the final answer here. How would I set this up? Huh?
8 over x.
Okay, we could go this over this equals this over this. This is an angle bisector down here. Or 8 over 12 equals x over x plus 2. Either one. Either way, when you cross multiply, you're going to get 12x equals that. Okay, if x is 4, then what is AB?
It'd be 12.
Right, 8 plus 12. So we gotta put 12. A couple more, I guess. 21. 21 kind of has a trick. We can 21 is very similar to 14. It's pretty much the same thing as 14. So there's two options. We could do 2a over 5a equals 140 minus x over x. But it also works. We could do the whole side like 140 over the bottom side x. What number is this, 21? You can use 140 over x, that's going to work too. Equals, well, what's 140 on the left side matches what on the right side?
5a. Or 2a plus 5a.
Yeah, 2a plus 5a, which is 7a. Over x on the left side matches what on the right side?
X plus
5a. Now, we could cross multiply right here, but what else could we do? You can reduce these like a divided by a. So we can just kind of get rid of the a's there. Anyway, cross multiply 7x equals 5 times 140. It's a lot of blessies. You are blessed. Hashtag. You guys heard that the reason that started is because they thought demons were coming out of the body?
I did it.
You got the demon out? Okay, how are we going to set up 23? Last one. This one's not, well,
x minus 5.
this might be hard. X minus, not setting it up, but solving. X minus 5/10 equals x plus 7/x minus 2. What makes this one challenging? How do we do that times that?
5x. Can you cancel those x's? I don't like that.
No. It's a FOIL problem.
Yeah.
We're ending with a bang here. You guys are lucky this isn't on. You guys remember how to FOIL? Rusty on your algebra? X times x. Outside.
It's 2x. Right? Negative 2x.
Minus 2x inside.
Negative 5x.
You guys are gonna have to remember this for next year,
Positive.
which is coming up on us fast, right? Plus 10. Okay, minus 2x minus 5x is
Negative 7.
how do we solve an x squared problem? We've done a couple of these this year.
Square root.
New. We move everything to one side and then probably factor it. So I'm gonna minus 10x minus 70 on both sides. That will get rid of everything on the left side. Okay, I'm getting more. All this math energy.
I should correct my
You guys remember how to factor this? No. Another thing you need to remember for next year. What goes into x squared?
x.
Time to panic. What multiplies into negative 60? We will relearn it next year, but if you remember, it's easier. What multiplies into negative 60 that adds up to negative 17? Remember, it's in the times tables. Barely. Oh,
12 and 5.
never mind. I was thinking 12 and 5. 12 and 5 doesn't work because you'd have to use like a negative and a positive to multiply to negative 60. But that would add up to, what else goes into 60 besides 12? 6 and 10, that doesn't add up to 17.
18. Nope.
What?
3 times 20.
3 and 20? Okay, but one of them has to be negative, right? Which one do we want to be negative to add up to negative 17?
The 12, or the 20.
Yeah, the 20, because 3 minus 20 is negative 17. So it's that. And then the last question, so if this times this equals 0, what x values would make one of these 0? Because if this times this equals 0, we need one of these to be a 0. So what x value would make this a 0?
Negative 3.
What x value would make this a 0? Positive 20. So these are our two options. X is referring to the length of something, so it's not gonna, the negative's not gonna make sense. So it's 20. Is 20 all we were looking for? Yeah, it is. Whew, that was a doozy.
Please, Doctor.
Is 22 that hard?
No.
You already did it, so.
Yeah, it is. It's the same kind, but it's not as big, the numbers. Yeah, Kale.
Oh, okay. I think I did.
Yeah, when you cross multiply, you should get an x squared on 22.